Today, the puzzle that I'm going to solve is called reverse Minesweeper. I know I have to use 2D array to complete this puzzle. If I read the goal of the puzzle, it will tell us what I need to do. Given a grid of mine locations where dot are empty cells and X are mines, your goal is to display the grid like it appears if you win the game. Each position is a digit indicating the number of mines bored in it, including diagonals. The mines X don't appear anymore. Mines are positions that do not board any mines both appear as empty cells. I'm going to continue using JavaScript, and if we look at the input right here, it will tell us what each line does. So for the first line, it is an integer for the width of the grid. For the second line, it is an integer for the height of the grid. For the for loops, is for each line of the minefield with dots and mines. And finally, for the output is for h lines of width, showing the computer gain of Minesweeper. Let's look at the constraints. 1 less than equal to w is less than equal to 30. 1 less than equal to h is less than equal to 30. This is the example right here, so they tell us the input and output. To start things off, I'm going to continue the const because they already helped us with the width and height. The two constants I'm going to include are grid and neighbors. So for grid, that we're going to equal to the we're going to equal to ellipsis array height, and we're going to map that. So what map function does, it calls a define callback function on each element of an array and returns an array that contains the results. We're going to use an underscore. We're going to use the arrow function, read line. We will split that. So what that does is splits a string into substrings using the specify separator and returns them as an array. We will split it by an empty string. And for neighbors, we will do this. We will use two arrays, so -1 equals -1. For the second one, we will do 0 -1. For the third one, we will do 1 -1. For the fourth one, we will do -1 0. For the fifth one, we'll do 1 0. For the sixth one, we'll do -1 and 1. For the seventh one, we'll do 0 and 1. For the eighth one, we'll do 1 and 1. And that's it. So what I did right here is literally trying to find all the positions for 1, 0 and -1, which will help us for the dots and mines. I'm going to add two for loops. The first for loop is I'm going to do is use for the height. So to do this, I'm going to use let y equals to 0, y less than height. We're going to plus y, and we're going to do another for loop, and this one's for the width. So to do this, we're going to do for let x equals 0. If x is less than w, we will increment x. I'm going to do an if statement. So let's do if grid y and x is equals to x. We will use neighbors and wrong. And the first thing I'm going to do is map. So what map? Yeah, so that's what map does. I already explained it on the previous lines. So we will use let's use dx and dy. So that's for diagonal x and diagonal y. So diagonal like width and diagonal height. And we will use the owl function to this. So let's do x plus dx, y plus dy. We're going to use the filter. So the filter, it returns the elements of an array that meet the conditions specified in the callback function. To do this, I'm going to include both x and y, and we'll use an owl function again. X owl function 0 and x is less than w and y is greater than or equal to 0 and y is less than height. We're going to add another filter, and for this one it's similar, but you'll find out the difference. To do this we're going to use both x and y. We will use an owl function grid y and x, which is not equal to x. And finally, in this for loop, we're going to add a for each. For each. So what that does, it performs the specified action for each element in an array. So to do this, we will do x and y, which is and we're going to use an owl function, and we're going to use grid y and x, which is equals to plus grid y and x, and we're going to plus that by 1 or 1. That was quite a lot there. So if I research them, so let's, for example, I mean, it already tells us. What do I need to research actually? Yeah, the owl function. I use a lot of owl function right here. So let's do right here, JavaScript. An owl function expression is a compact alternative to the traditional function expression. That's not really. Yeah, okay. Okay, it's a new feature that introduced. Okay, so yeah, right here. The left part denotes the input of a function, and the right part of the output of that function. So you can see it right here. And finally, to print it, we will do another for loop. So let's do grid for each row owl function, and let's print it out. So console log, we will print row join empty string, and I want to replace that. So it replaces first match with string, or all matches with this. And I want to replace x, g, dot right here. Yeah, so this is a says right here. Mines are positions that do not border any mines, both appear as empty cells. Let's use the semicolon, and that should work. And let's add this comment again. It should work. Let's do it again. Okay, it works. 100%. Well, this is a short episode compared to my last one, and if you stay to the end, I really appreciate that. And I'll see you in the next one.